आज इस वीडियो लेक्चर में हम डिस्कस करेंगे व्हाट इज न्यूटन्स यूनिवर्सल लॉ ऑफ ग्रेविटेशन. नाउ दिस टॉपिक इज एक्सट्रीमली इंपॉर्टेंट बिकॉज एज लॉन्ग एज यू आर अ साइंस स्टूडेंट आपको न्यूटन्स यूनिवर्सल लॉ ऑफ ग्रेविटेशन को यूज करना है. सो आई विल ट्राई टू एक्सप्लेन दिस इन द सिंपलेस्ट वे. आई होप यू एंजॉय दिस वीडियो. सो विदाउट एनी फर्दर डिले विल स्टार्ट विद द लेक्चर. According to this theory, according to this law, Newton said every object in the universe attracts every other object with a definite force. Now this statement was given by Newton. We'll try to understand this. According to Newton, universe में if there are objects, they will always attract each other with a definite force. This definite force is nothing but your gravitational force. This is your gravitational force, and if you remember, this force is a weak force. This force is a weak force. Now, to find the magnitude of this definite force, that is gravitational force, we have a derivation. According to Newton, Newton gave us some relations that are very important. According to Newton, the magnitude of this attractive force, which I will represent using F, he said that this is directly proportional to the product of the masses of the two interacting bodies. Let's say this is equation number 1. And the second relation that was given by Newton, it says the magnitude of this attractive force is inversely proportional to the square of the distance between the two interacting bodies. Now to understand this, I will use some diagram. So for now, we will take an example. I have considered two spherical objects. I say that the mass of the first object is m1 and mass of the second object is m2. We just assume this, that the masses are m1 and m2, and in this diagram I have marked the centers of the two interacting bodies. Now look at this. To measure the distance between the two interacting bodies, we will need to know the exact geometrical centers of the two bodies. So I have marked the centers. From this I will draw a line. And if you measure the distance, let's say that the distance between the two objects is small d. The distance between their bodies is small d. There's one thing that you need to make sure that the distance between the bodies is measured from the centers of the two interacting bodies. For example, if you look at this, if I measure the distance from the circumference of these two circles, so this is wrong. We cannot do it in this way. Always remember the distance should be measured from the centers of the two interacting bodies. So now look at this, look at the relations given by Newton. This force is directly proportional to the product of the masses m1 into m2, and the second relation is the attractive force, that is gravitational force, is inversely proportional to the square of the distance between them. Now if you look at this, if I increase the mass of the two bodies, so the magnitude of this force will also increase because the relation is directly proportional, and the second relation is inversely proportional. So what it means, if I increase the distance between them, the magnitude of this force will decrease, and vice versa. If I reduce the distance, then the magnitude of this force will increase. I hope the relation is clear to you. Now what we will do, we have equations 1 and 2. I will combine them. So from equation 1 and equation 2 we get the attractive force is directly proportional to m1 into m2 upon d square. I hope till here everything is clear to you. We will mark this relation as 3. Now to remove this proportionality sign, there is a rule. When we remove this proportionality sign, we introduce a constant in the given relation. So this equation can be written as F is equal to m1 m2 divided by d square, and in place of this proportionality sign I will introduce a constant, that is capital G. Now this capital G is very important. This is known as universal gravitational constant. universal gravitational constant. If you talk about the magnitude of this constant, the magnitude is 6.67 multiplied with 10 raised to minus 11, and the unit of this constant is Newton meter square per kg square. Now I'll explain you how to derive the unit. Consider the same equation. We know force is equal to capital G into m1 m2 divided by d square. Now in this we know that the SI unit of force is Newton is equal to, we need to find the unit of capital G, तो इसको ऐसे ही रहने देंगे. And if you look at m1 and m2, these are two masses and mass is calculated in terms of kg. If I talk about SI unit, mass is calculated in kg. So G will be multiplied with kg into kg divided by. Now if you look at this d, d is nothing but the distance between the two bodies, and distance is measured in terms of meters when we talk about SI unit. So here we have square of the distance, so we will write m square. If you solve this, Newton is equal to capital G, kg into kg will be written as kg square upon meter square. Now we are only concerned with the capital G, so we will shift the rest of the terms. Therefore, the unit of capital G turns out to be m square will be multiplied with Newton. So Newton meter square, and this kg square will move into the denominator position. So this is Newton meter square per kg square. This is how we derive the unit. If you want, you can just remember this, the unit, and if you want, you can understand how to derive this. आपको ये 1 mark MCQ में पूछ सकता है what is the exact value of capital G and what is the unit. So in any way, it's up to you. Whichever method is easier for you, go with it. So now again I'll repeat the law. This is very important. आपको ये 2 marks के लिए derivation आ सकता है. According to Newton, every object in the universe attracts every other object with a definite force. Now this definite force is nothing but the gravitational force, and as I said, it is a weak force. Newton gave us some relation. The first relation is this attractive force is directly proportional to product of the masses of the two interacting bodies, which means if you increase the masses of the two interacting bodies, the magnitude of the attractive force will also increase. And the second relation is the attractive force is inversely proportional to the square of the distance. It is inversely proportional to square of the distance, which means if you increase the distance between them, the magnitude of the force will drop, it will decrease. Now if you combine both the equations, you end up having this relation: F is directly proportional to m1 m2 divided by d square. To remove the proportionality sign, the rule is we introduce a constant, and that constant is nothing but your universal gravitational constant, whose value is 6.67 into 10 raised to minus 11. So I hope this is clear to you what is Newton's law of gravitation. Now there are some key points that we derive from the Newton's universal law of gravitation. I'll just copy the final formula that we just derived from Newton's law. According to that, the gravitational force is equal to capital G multiplied with m1 m2 divided by d square. This was the formula that we derived using Newton's law. In this we know m1 is the mass of the first object and m2 is the mass of the second object, and d is the distance between them measured from the centers of the object. Now key points mein there is this first point which says if of any one of the object mass of any one of the object is doubled. So this is the case that is given to you. मान लो we have two objects. First is m1 and the second is m2. Initially the masses are m1 and m2, but if I increase the mass of any one of the objects such that the new mass is twice the initial mass. For example, if I say the mass of the first object is now 2m1. So what will happen to this? Let's say ये जो हमने फॉर्मूला लिखा है, I mark this as F1 which represents the initial force. Now the new force represented using F2. This will be given by capital G multiplied with. Now the mass of the first object is not m1, it is 2m1. So this will be into 2m1 multiplied with m2 divided by d square. So now what will happen to the new force if you increase the mass of the object? So this 2 can be written at the first position. I can write this as F2 is equal to 2 multiplied with J into m1 m2 divided by d square. Of course we can write this because in multiplication we can rearrange the terms, it is commutative in nature. So now if you look at this term जो मैंने इसमें mark किया, this is nothing but your F2 is equal to 2 times F1. Look at this, the formula for initial force was given by capital G into m1 m2 divided by d square. तो इसमें सिंपली हमने जस्ट इतना ही किया है, जो 2 हमारा फैक्टर था इसको पहले लिखा है. So the rest of the term is nothing but the initial force. So what I can say, if you increase the mass, if you double the mass of any one of the object, then the new force is twice the initial force. This is very important, ये आपको 1 mark MCQ में आता है. So just remember this. इसके बाद there is second point which is related to the distance between the two bodies. It says if distance between the two objects is doubled, so what will happen to the new force? Again I'll use the same representation. Let's say the new force is F2 is equal to, now mass is constant, हमने इस बार mass को change नहीं किया, so this will be m1 into m2 divided by, but the distance, again I'll draw a rough diagram, mass is m1 and mass is m2. Now the distance measured from the centers is not d, it is actually 2d. The distance between them is 2d. So denominator में in place of d square, now we will have 2d whole bracket square. So denominator में हमारे पास आएगा 2d whole bracket square. Now if you solve this, so F2 will be capital G into m1 m2 divided by 2 square is 4 and d का square will be d square as it is. Now in this I will just modify this equation. F2 is equal to, I will write 1 upon 4 multiplied with G m1 m2 divided by d square. Now if you observe this term, again this is nothing but your initial force. F2 is equal to 1 upon 4 multiplied with F1. So what can you say from this equation? If you double the distance between the two objects, the new force will be 1/4 the initial force. The new force will be 1/4 the initial force. Again, this is important from 1 mark MCQ point of view. So be prepared for both the conditions. They may ask you a question based on modification in the masses or modification in the distance between the two objects. Now in this case what we have done, we have only considered, if you just look at this, I have only considered if the mass of any one object is doubled. ऐसा भी हो सकता है that mass of both the object is double. So in that case the new force will be 4 times the initial force. And if I talk about this, जहाँ पे हमने consider किया that the distance between the two objects is doubled, ये भी हो सकता है that the distance is increased by 3 times or 4 times. So it is very easy, you can just try these at your own. For example, if I say that the distance between the bodies is increased by 3 times, so what will happen? The distance will be measured as 3d. So the new force will be F2 is equal to G m1 m2 divided by 3d square. बस हमने d को replace किया with 3d because the distance is increased by 3 times. So this equation will be G into m1 m2 divided by 3 square is 9 d square. So the new force will be 1 upon 9 times the initial force. This is how you can develop the relations based on the question. You should be prepared for this, but the basic idea should be clear to you so that you can solve if the question is a bit tricky. So this was all about Newton's universal law of gravitation. इससे related जितने key points थे हमने देख लिया. But now in the previous lecture in which we discussed about Kepler's law, in that if you remember मैंने आपको second law बताया था. If the orbits revolve in elliptical orbit, if the sun is at any one of the foci, for example at this position, so planets sweep out equal areas in equal interval of time. कुछ इस तरीके से हमने डायग्राम ड्रॉ किया था at different position. So I said that if the planet is at the far end, it will move. The planet is said to be moving slower, and if the planet is at the near point, it is said that it is moving at a faster rate. Now I said that I will explain you this topic when we discuss Newton's law. So we'll just discuss about this. I have drawn the orbit which is elliptical and the sun is at any one of the foci according to Kepler's law. Let's say that the planet is at this position which is at the far end. Let's say the position is at point A, and I assume another position of the same planet. I say that the planet is at point B. Now we'll at the first case, in the first place I will discuss about point A. If I join the sun and the planet using a line, I will say that the distance is d1. Let's say the distance is d1. So I can say the distance SA is equal to d1. Fine. Now if I join sun and the planet at point B, I will say that the distance now is d2. So I can say the distance SB is equal to d2. Now from the diagram itself you can say that the distance d1 is greater than d2. Correct. Now what we discussed in the last lecture, that if the planet is at point A, it will move slow as compared to when it is at the near point. Now what is the reason? Back to Newton's law. According to Newton, the attractive force is inversely proportional to the square of the distance between them. So what did we learn in this lecture? If you increase the distance, the magnitude of the attractive force decreases. So if I talk about position A, the distance is large as compared to near point. So what happens if you increase the distance, the attractive force which is exerted by sun on this planet decreases. It keeps on decreasing. So this is why when the planet is at the far end, it moves slowly. Whereas when you talk about the planet at position B, so the distance is very small. So if the distance is very small, the magnitude of the attractive force exerted by sun will increase. So this is why when the planet is at the near point, it moves at a faster rate, and when it is at the far end, it moves at a slower rate. I hope this is clear to you. So this was all about Newton's universal law of gravitation. We have discussed the statement of this law, the relations that we have, equation 1 and 2, and key points related to Newton's universal law which are important from MCQ point of view. I hope everything is clear to you. In the next lecture, what we will discuss, if you look at this second equation, which says the attractive force is inversely proportional to the square of the distance between the two objects. This is also known as law of inverse square. So in the next lecture we will discuss why did Newton assume that f is inversely proportional to the square of the distance. Why did not Newton say that it is inversely proportional to the distance, or Newton could have said that this force is inversely proportional to the cube of the distance, but Newton said that it is only inversely proportional to the square of the distance. So in the next lecture we will discuss why we consider only the square of the distance. Till then, thank you for watching this video. We'll meet in the next lecture.